Hello everyone, I am Mohit Karwade. My topic for presentation is Access Control Levels guided by Professor Poonam Lohakare Ma'am. Access Control Levels: Public, Private, Protected, a recap. Delving into the fundamental concepts of access control in programming, this presentation will demystify the roles of public, private, and protected access modifiers, ensuring robust and maintainable codebases. Why access control matters. Securing your code. Access control isn't just about hiding data, it's about establishing clear boundaries and responsibilities within your code. It's the bedrock of good software design, preventing unintended modifications and ensuring system integrity. Just as a well-guarded vault protects valuables, access control shields your code's critical components. Enhances code readability and maintainability. Minimizes the risk of errors and bugs. Facilitates team collaboration and parallel development. Understanding access modifiers in programming. 1. Definition: keywords in object-oriented programming that set the accessibility of classes, methods, and variables. 2. Purpose: to implement encapsulation and manage the visibility of program components. 3. Impact: directly influences how different parts of your application interact and access information. 4. Varieties: primarily public, private, and protected, each serving a distinct purpose in controlling access. Public access: universally accessible components. The public access modifier signifies that a class, method, or variable can be accessed from any other class or package. Think of it as a public announcement board, visible to everyone. While convenient, overuse can lead to tightly coupled code and reduced security. Accessible from anywhere in the application. Forms the primary interface for external interaction. Should be used judiciously for core functionalities. Private access. Encapsulating internal logic. The private access modifier restricts access to members within the same class. It's the ultimate form of encapsulation, shielding internal implementation details from the outside world. This promotes robust code by preventing direct external manipulation of critical data. Accessible only within the declaring class. Essential for data hiding and preventing side effects. Promotes a cleaner, more modular codebase. Protected access. Access for inherited classes, subclasses, only. The protected modifier allows access to members within the same class, subclasses, even in different packages, and classes in the same package. It provides a balance between public visibility and strict privacy, often used for members intended for extension and specialization by derived classes. Accessible within the class, subclasses, and same package. Crucial for supporting inheritance hierarchies. Offers controlled access for customization. Public, private, protected. A comparative summary. Modifier. Access scope. Typical use case. Public. Anywhere. External APIs, core functionalities. Private. Within the class. Internal state, helper methods. Protected. Within class, subclasses, same package. Members for inheritance, extensible components. Best practices for choosing the right access level. Default to private. Start with the strictest access and broaden only when necessary. This minimizes exposure and enhances security. Expose what's needed. Only make members public if they are part of the intended public interface of your class. Less is more. Consider inheritance use protected when you intend for subclasses to access or override specific behaviors. Common pitfalls and how to avoid them. Overuse of public leads to tight coupling and makes refactoring difficult. Avoid exposing internal data unnecessarily. Ignoring encapsulation, directly accessing variables instead of using getters, setters. Avoid bypassing access modifiers. Incorrect protected use, using protected for members not intended for inheritance. Avoid misinterpreting its scope. Lack of consistency, inconsistent application of access levels across a project. Avoid disjointed access strategies. Key takeaways and further exploration. Mastery. Effective use of access control is a hallmark of good programming. Clarity. It provides clarity on responsibilities and interactions within your codebase. Robustness. Adhering to principles of encapsulation leads to more robust and maintainable software. Continue exploring design patterns like the facade or adapter to further understand how access control underpins complex system architectures. Thank you.